So let's talk about the expected value for discrete probability distribution. And specifically, if we come across a problem in some context, how do we calculate that expected value and how do we interpret it? So our first step, always, whenever we come across some word problem that asks us to find the expected values, we want to think, can we create that probability distribution table? If we can build that table, then the second part where we actually do the calculation is straightforward. We can either use StatCrunch, which is under Stat Calculator's custom, or we can just do it by hand and calculate it by finding the sum of every single value times the probability of that value in the table. And thirdly, we want to make sure we understand what is this expected value actually representing. So we should be able to write a sentence that interprets it. And every good sentence will always use that definition of an expected value as an average in the long run. So you want to make sure that somewhere in your sentence you're incorporating that it's an average or a mean, and that this is over many trials in the long run and not just after one or two. Lastly, that interpretation should be in context with the correct units. So there's a couple of different scenarios that we're going to take a look at today with some tips on looking at those scenarios. Of course, expected value can be applied to many different situations, but two of them in particular that we're going to look at are one, games of chance, and two, when we look at some kind of warranty or insurance type of application. So when we're looking at some games of chance, some tips that we may want to consider is a lot of times in our word problems, we're always going to look at what's the winning outcomes. But implied in any kind of game of chances, there's a chance of losing and it might not be listed. So we want to make sure we consider that and what's the probability of losing when we're building our table. And second, if there's any cost to play the game, we could either put that into the table itself, or we can just consider this as something we're losing at the very end after we calculate the random variable's expected value. So let's take a look at an example of that, in example one here. A school is running a fundraiser selling raffle tickets. There's one grand prize worth $500 and three smaller prizes, each worth $50. If each ticket costs $5 and the school plans to sell 1,000 tickets, what is the expected value of winnings for playing this game? So let's talk about X being the amount that we kind of win from playing this game. And we'll ignore the costs right now. So this goes back to this one right here. How are we going to deal with that cost? I tend to ignore it at first and then plays a role at the very end. So if X is just the amount that we win from the game, then what could we possibly win? So we have to think, what are all these possible values? Well, one, we might win something worth $500. Two, we might win something worth $50. But again, going back to this other thing to kind of consider, even though those are the only prizes, what happens if we lose? Well, we don't win anything. So now we can go and think about what are the chances of each of these prizes. If there's one grand prize out of 1,000 tickets, then that would be a 1 over 1,000 probability, or as a decimal, 0.001. For second prize, or the smaller prizes, it's $50, but what's the probability of them? Well, 3 people will win that out of 1,000, so that would be 3 out of 1,000, or as a decimal would just be 0.003. And then finally, we get to the one, well, what happens if we don't win one of those? Well, we must be one of the losing prizes. Well, how many tickets are going to lose? So far, we have 4 winning tickets out of 1,000. So that leaves us with 996 out of 1,000 that are losing. And if we put this in as a decimal, we see that that gives us 0.996. And again, we can verify that this is a valid distribution, that we have every single value, because all of these probabilities should add up to 1. And we see that 0.001 plus 0.003 plus 0.996 definitely add up to 1. So let's think about now the next step. How do we calculate this actual expected value if we're going to have this as our distribution? Well, the first way we can do this is using StatCrunch. The second way is by multiplying and adding. So let's do the multiplication way by hand, and then I'll show you StatCrunch right afterwards. So in this case, we're just going to take every single value times the probability. So if we have 500, we're going to multiply it by its probability of 0.001. And we're going to do this for every single outcome and add them together. So next we have 50 times 0.003, and then we're going to add 0 times 0.996. And if we add all of those values times the probabilities and add them all together, we get our final answer of 0.65. And there's the expected value for how much each ticket could possibly win. Now, when we're talking about winnings, I guess another word that we should probably add in here is of net winnings, meaning that's only if we don't play or have to pay for this ticket at all. But what if we have to pay $5 to play this game? Well, if we win on average 65 cents, well, we got to subtract that. Okay, we won 65 cents, but we lost $5 to play. And so really, what we have is we're going to lose a negative amount, $4.35. And there we go. There is our expected value for playing this game, for our net winnings. On average, what we see is we're going to be losing $4.35 if we played this many, many, many times. And that's now step 3. Let's go ahead and write an interpretation. So again, we want to make sure that if we write this interpretation, we talk about it as being an average or a mean in some way. It's in the long run, and we have some kind of context with the correct units on this. So we can say something like, on average, we expect to lose $4.35 each time we play this game if we play many times. And this is just one possible way we could have worded this, but you notice I have the average. The long run is interpreted by the fact that I'm saying if we play many times. And we have it in context, right? We're losing this $4.35 each time we play the game. So we have some context with the units as dollars in this case. And there we go. We have all 3 parts to this. So one thing I'll go back to is, let's go back, look at that step 2. I did this by hand here. We could have also used StatCrunch to answer this question for us. So if you notice on StatCrunch, I've actually just entered in the table already right here. We have the 500, 50, 0, we have those probabilities. So if we just follow those steps that we did, stat calculators custom, so stat calculators custom, our values are the values for x, and then the probabilities, I had put them in P of x. And now what we'll get is an actual calculator where we can calculate probabilities, but what we need is the mean. That is the expected value. A mean is the expected value. And so rather than doing it by hand, we could have just done it there, and we see the 65 cents that we found is the same 65 cents that StatCrunch found, and then we can do the rest of it the same. Let's look at one more example of this. This time we'll look at the situation where we're looking at warranty or insurance. So just to make sure we understand some of the key things to watch out for in this case is what a warranty is people pay into this, and if something breaks, or for insurance case, if someone dies, then the company has to pay them back an amount. So the hope is that for the company, not everyone's going to need this warranty or need this insurance, so they just get the amount that they pay. So one key thing to watch out for, though, is that the cost that they pay for the insurance or warranty is earned by the company no matter what, whether the thing breaks or not, or the person dies or not, or they have to have a claim or not, they always pay. So if someone dies for life insurance, or if a person does need to worry about replacing their thing for a warranty, then they end up making that money, but they have to subtract out how much they have to pay out for that benefit. So in terms of a warranty, like some of the terms you might see is how much they're charging, and then how much they lose is the replacement cost. So how much the company makes or loses would actually be the charge minus the replacement cost, because they earned this amount, but now they have to lose the replacement cost. For insurance, the amount we charge is, we tend to use the word premium for that. So a premium is how much they're charging minus how much they have to pay out for a policy. So we would be able to figure that out here. So let's look at that example in this case, and then we'll do the exact same thing we did before. So an electronics retailer offers an extended warranty on a specific television. They charge the customer $36 for the warranty, but if the television breaks, it'll cost them $525 to replace the television. They estimate that 2.2% of the televisions will break within the extended warranty period, and we want to know what is the expected value of profit for the retailer for selling this warranty. So as always, when we read a question, our goal is to first, can we write that table? And so going back to those things to watch out for, well, obviously one thing that might happen is we charge the customer $36 and we get to keep that money, right? Their television works fine. We're like happy because we have their $36. They're happy because their television is still working. On the other hand, what's the other thing that can happen is we still charge them $36, and I'll put this off to the side. So this is still how much we charge them. But what if their television breaks? Then as a company, I made that $36, but I have to replace that television. So there's a replacement cost, and it's going to cost us $525. So now we actually see that the amount that they're going to lose is not the full $525 because they earned that $36 before, but they're actually just going to lose $489 on this customer since they charged $36 initially. So that's the other option, right? How much is going into their profit is either $36 for this policy or they lose $489 on each policy. What are the probabilities? Well, they gave us one of the things, 2.2% of the time it will break. Well, if it breaks, that's when they have to replace it. So that 2.2% or 0.022 as a decimal goes under the probability. And now we have to think, well, if there's a 2.2% chance that it's going to break, what's the chance that it's not going to break and we just get to keep their money? Well, it's the complement, because remember, it has to add up to 1. So if we did 1 minus 0.022, we see that there's an actual 0.978 probability that their television will keep working. And now we have our table. Step 2, let's find the distribution expected value. So looking back at our table, so I put that same exact table here. Again, we're just going to do stat calculators custom, choose our variable as the values, choose our weights as the probabilities, compute, and we see the expected value is 24.45. So the expected value for our amount of profit we make is 24.45. And now finally, we just have to find and interpret this answer. So we can say something, I'll just write it a little bit differently. If the company sells many policies, right? This is where we get in the long run, right? If they sell many policies, or sorry, warranties. If they sell many warranties, then they will make an average of $4.45 per policy. And so we, warranty. So what we see, again, is we have in the long run is represented by selling many warranties. It's an average, and it's in context. We're talking about warranties, cost, and then making $24.45.